And this question it is given that a wind with a speed of 40 meter per second blows parallel to the roof of a house. The area of roof is 250 meters square. Assume that the pressure inside the house is atmospheric pressure. The force exerted by the wind on the roof and the direction of force will be. So over here, consider that there is a house, and here we can take it as the air which is inside the house is at rest. So velocity of air inside we can take it as is equal to 0, and some wind is flowing or air is flowing with some velocity, take it as v2 above it, and that velocity is given as nothing but 40 meter per second. Parallel to the roof of house, the area of roof is nothing but its area of cross section is also given. Its area is given as nothing but around 250 meters square. Assume that the pressure inside the house is atmospheric pressure. So pressure inside we can take it as nothing but atmospheric pressure. The force exerted by the wind on the roof and the direction of force will be. So we can apply a Bernoulli's theorem between this point 1 and point 2. So we can take it as pressure at point 1 plus half into rho into V1 square plus rho into G into H1 is equal to pressure at point 2 plus half into rho into V2 square plus rho into G into H2. Now there is no that much difference between gravitational potential energy, so we can just consider that these values are almost same, or we can cancel it. Now pressure inside P1 we can take it as nothing but atmospheric pressure plus we can write this as half into rho into v1 square, and the value of velocity inside is also equal to 0, so we can write this as 0 plus this term we cancel is equal to nothing but the value of pressure outside. So let's say that pressure outside is equal to P2 plus over here we don't know exactly what about the value of pressure outside, as a fluid is moving, it's not equal to atmospheric pressure, or air is moving, it's not atmospheric pressure, where the value of velocity is more, pressure is going to decrease. Let's say I'm just taking it as nothing but P2 plus we can take it as half into rho into V2 square. We know the value of V2 which is equal to 40 square. So we know that when there is a flow of air, pressure is going to decrease. So the difference in pressure we can write delta P is equal to atmospheric pressure, which is pressure inside, minus pressure outside, which is equal to half into density of air is given as nothing but 1.2 into 40 square, which we can take it as 1600. So we can write this is equal to around 0.6 into 1600. Now our aim is to find out what about the value of force. So we can write this force is equal to difference in pressure into area, and pressure outside is less, so the net force is going to act in upward direction, and difference in pressure is 0.6 into 1600 into the value of area is given as nothing but 250. We'll get it as around 2.4 into 10 raised to 5 Newton, and its direction is upward because inside pressure is more as compared to that of outside.